which is the name of our frictional model, our frictional element. With several isotopes, determine the average atomic mass using beads, cups, and the analytical balances. You know where those are. There's two there, and there's one over there. Okay? All right. So, and we have our models. All right? We have been talking about calculating average atomic mass using our models. What do these beads represent? Write your background info and write a procedure. Show me your procedure, and I will give you your obedience. Okay?
Eyes up here, please. Quick review what we talked about yesterday. Yesterday I had you answer this question. You wrote it in your notebooks. We had a whole discussion about how would we get ocean creatures, ocean organisms, in rocks that are thousands of feet above where the ocean is today. All right, that top layer. But what I want to do today is, I want to pretend that we have the ocean that was there hundreds of millions of years ago. And so what we did was, I told you yesterday, we're going to do a lab where we're simulating the ocean from hundreds of millions of years ago. Okay? We don't have ancient organisms alive. You guys are going to be the ancient organisms. We don't have the ancient ocean here, but I mixed up a solution that is going to simulate what the ocean was like hundreds of millions of years ago. And so what I told you, what is this representing? What is this representing? Yeah, true. Yeah, this is the ocean.
We're going to blow into one of the straws.
You're going to be blowing into the straws, okay? What do your bubbles represent?
Waves.
What do your bubbles represent? Ancient creatures, okay?
All right, so model. What's a model? What do you know about models? Because we've used so many models, and I would be so disappointed if everybody...
It's like a mini version of something, but it doesn't have all the pieces.
Well, it doesn't have to be an object. Well, it does, sort of, but it can also be a picture. It just has to be a replica of something that can be bigger or smaller.
Yeah.
To show.
Like another thing, but not exact.
Yeah. Can we learn? Wait, I'm going to show you a model of solid, liquid, and gas, what the particles inside do, or the atoms, as Claire had mentioned earlier with her advanced science knowledge. So we're going to pretend that inside this is where the gas molecules are, kind of like this. So what do you notice about gas, the way it acts? Ava?
It bumps into different particles of it and floats away.
Solid, Hamam. How am I going to turn this into a solid?
Well, I don't know, like how that,
No, we shouldn't. Yes, Claire.
it stays all in one place. It just stays together really, really tight.
You're going to find a bunch of stuff over here on the counter. And the first step says to collect materials. Each group needs a beaker, a small beaker. You're going to want a striker, which you can share as you go. Okay, if you're still drawing or observing, please move on so that you're at the same spot.
Oh, I see. It's like cleaning it or something. Is it like cleaning it? I don't know.
That's a good question. With tongs and put them directly in the flame. 30 seconds only.
This one did it the best.
That one is the best.
So it like turns gold. We keep the penny.
Yes. When we heat the penny with the other chemicals, we galvanize the penny. GAL. To our next question, which is, where do we think the gold comes from? Who has ideas about where the gold comes from? Is it real gold? How did you know, or how could you know, even before we have this discussion about brass, that it's not probably real gold?
Because we didn't even start with gold to begin with.
If it was real gold, I think.
1, 2, 3, 4. All right, group 5, Alyssa and Julia.
She's a really great
Group
teacher.
6.